Now, as well as adding, subtracting, multiplying and dividing functions, we can also combine functions by having a function of a function. That is, when we put x, for example, x here goes into a function machine g, comes out of that function machine as something else, as g of x, and then goes into another function machine so that we get f of g of x. And that's what this notation here is. You see this f with a little circle and then g of x. That means f of g of x. So in example 1, we're given two functions, f of x equal to x plus 2 and g of x equals x squared. And we're asked to find things like f of g of 3. Now that means that you've got 3 going into a function machine g, which is going to be squaring it. So we're going to have 3 going into the function machine, being squared, coming out, and going into the f machine, which is going to then add 2 to it. So whenever you see f of g of 3, you can just write that with the brackets. That's usually the best thing to do. So you can get rid of the little circle and just write f of g of 3. You can then calculate g of 3. Now, since you know that the g machine is just squaring, that g of 3 is going to be 3 squared. So the next thing you're going to do is find f of 9. 3 squared is 9. So you need to find f of 9. And remember, the f machine is x plus 2. We have to add 2 to 9. Right? The f machine just adds 2 to the inside. So our final answer there should be 11. And you can see that the same kind of thing happens down here. You plug in -2 to the g machine. First of all, just write it as f of g of -2. Then g of -2, -2 squared is going to be positive 4. And then you add 2, because that's the f machine, to 4, which gives us 6. Now that was f of g of -2. That's when you did the g first, you squared it first. In this example here, we've got g of f of -2. So the first thing we're going to do here is take f of -2. Right, so we're going to find the f of -2 first. Now remember, the f machine was adding 2. So we've got to add 2 to the inside here. We're going to have to do -2 plus 2. So if we do -2 plus 2, what we get is 0. So then we have to find, and you'll notice I just had to change that to g of 0. There was a typographical error there. And then g of 0 should just be equal to 0. In the next question, it's f of g of x, which means that we have to take this g of x and just put it inside this function. So if you have a look at what happens here, we have f of g of x, just as before. Then we take that g of x, which is x squared, and we put it inside the f function. We just add 2 to the x squared, so we have x squared plus 2. Now it's worth noting that when you do f of g, it's not the same as doing g of f. You have completely different functions depending on whether you have f of g or g of f. Very quickly, the last couple of examples here. You take your f of x, just again write this as g of f of x. You take the f of x, which was x plus 2, and again there's a typographical error here, which I'll just try to fix now. That should say g in there. So we have g of x plus 2, and the g machine is just to square things. So what we then have after that is x plus 2 all squared. In that last example here, we've got a function inside a function inside a function. So a way of writing that is to say it's g of f of g of x. We take our g of x, and now remember that g of x was to square things. So we're going to replace this g of x here with x squared in the next part. So we're going to have g of x squared plus 2, because the f then adds 2 to the x squared. And then this g again is going to be squaring the x squared plus 2. So when we do that, we should get this. Now the last thing on this page is to look at decomposing a function, to try to split a function into two functions, right? This thing here we can think of as being a composite function, like these ones up here are composite functions. So what were the two functions that made up this function here? Now there are different answers for that, but one possible answer is to think of this function as being, first of all, you're having to subtract 5, and then you're having to do 1 over that. So one way of thinking about it is that you first of all subtract 5, and then you have to do 1 over the x minus 5. So the first function that we had to do was the x minus 5, and then the second function we had to do was the 1 over x. And you could write f of x equals h of g of x. This technique, incidentally, is useful when you go on to do calculus. You'll see this in something called the chain rule, where we have to decompose functions.